Chapter 3 focused on our solar system and the planets that it consists of. And one of the main emphases of this chapter was the vast distances these planets have between each other. And this can be modeled not really with a textbook, as it can't be scaled on a single page, but on our entire campus, which is what I did in this project. So, our sun is roughly 865,000 miles wide, and the soccer ball that you see placed at the feet of the Cathedral of Learning is about 8.5 inches wide as well. This creates a scale for us of 1 inch equals 100,000 miles, which will be using that scale to show proportionally where the planets would be on Pitt's campus. The first planet we see here is Mercury, which lies about 36.5 million miles from the Sun. This on our scale is about 30 feet from the basis of the cathedral. If we back up about 26 feet further, we'll find Venus, which is actually the hottest planet in the solar system, despite not being the closest. It lies at 66.8 million miles from the Sun, roughly. A little farther back, we have Earth, our home planet. Earth can be found about 93.95 million miles from the Sun, and it's about 78 feet from the soccer ball in our scale. Still relatively close to the cathedral, we find Mars, which is about 133.89 million miles from the Sun. This is about 112 feet from our soccer ball with our scale, and is part of the core 4 planets that are in close proximity to the Sun. Now, all the way across Forbes Avenue, we find the gas giant Jupiter. Jupiter is about 460.74 million miles from the Sun, and it's about 384 feet from our soccer ball. And it's important to remember, 1 inch is 100,000 miles, so we're now getting really, really far from our original Sun. Backing up a little bit further, we now find the ringed planet Saturn. Saturn is 915.39 million miles from the Sun, roughly 763 feet from our soccer ball, and you're really now starting to see how far of distances are between these gas giants. Vastly different from what we saw from the first 4 planets in our model. By the time I cross the bridge to Shenley Park, I reach where Uranus would be in our model. Uranus is 1.83 billion miles from the Sun, roughly 1,524 feet in our scaled model, far, far away from that original 8-inch soccer ball. After a considerable amount of walking, I reach our final location, Neptune. As you can see, the Cathedral of Learning is now far off in the distance as I'm halfway up Flagstaff Hill. Neptune is 2.78 billion miles from our Sun, roughly 2,317 feet by our scale. Looking back on the original basis of our model, it becomes apparent just how vast the scale we're dealing with is. It's no wonder satellites like Voyager take years and years to reach the outer portions of our solar system, even with the gravitational boost from other planets they receive. We'll see how the future of space travel deals with these enormous distances in the future, as it's quite the tall task.